This is an actual sprinkler system being built in SprinkCAD 3D. The first command we'll look at is control surfaces. Control surfaces take the place of SprinkCAD Classic's TOS commands. So the command is add control surface. The user selects any set of points, creating a polygon shape. Once the polygon has been created, 3 control points are selected, which control the elevations of that control surface. The second control surface in our example will be created off screen. The third control surface will be a flat surface. So the shape is created using 4 points, and then we'll set the elevation to 20 feet. The original 2 control surfaces will be sloping, and we'll edit the data for those control surfaces in the AutoCAD Properties palette. You'll notice that in SprinkCAD 3D, many of the SprinkCAD objects are either editable or visible through the AutoCAD Properties palette. And there's the result, 3 control surfaces. And now we'll look at the Bay Layout tool. So, very much like the classic SprinkCAD version, we'll select 3 points to define a bay. Lower left corner, lower right corner, and the upper right corner. And the bays can be at any angle. Now we select a sprinkler head, specify the spacing, and in this case we'll set the elevation from a control surface, and the heads and piping will respond to the control surface. Second bay is completed off screen, and the third or flat bay is performed last. All that needs to be done is to choose the different control surface, and that piping will be flat. Now we'll insert the solid model. We do this now just to point out that you can do it pretty much at any time during the life of your design. The command is insert solid model, and then next we'll isolate layers so that we can see the solid model more clearly. And then we'll set the view style to realistic. And here you can see the excellent detail of the solid model. It's perfect for use with Navisworks. We also support IFC export, Revit, and Kobe data. Now we'll insert sprinkler heads in the office areas. The command is insert heads, and we select the sprinkler head again from the list of heads that we've created. We'll set the elevation in this case at an absolute elevation of 8 feet, and then we set offsets. In this way you can pick a specific point and the sprinkler head will be inserted relative to that point. In this instance you can use a background that is laying flat on the ground, as this one is, and the heads are placed relative to that snap point but at the elevation that you specify. It's even possible to use control surfaces as your reference plane. Once this room is complete, the next 2 rooms will be completed off screen, and then we'll take a look at the room with ceiling tile at an angle. By changing the rotation along with the offsets, you can adjust for a rotated tile pattern. And based on the 2-foot square pattern, a 12 by 12 offset works here. And rather than having to do the math for the angular adjustment, you simply set the angle to match the tile. Now we'll see the office heads have been inserted at an elevation of 8 feet. Now we'll draw some pipe. The command is draw pipe. We specify a pipe name and then a code followed by a size. The code is made up of material, schedule, and finish, and the names are completely arbitrary. You can customize them any way that you like. Here we'll draw underground pipe at an elevation of -3 feet. And then we'll draw some vertical pipe. Now it's not necessary, but we switch to an isometric view in order to get access to AutoCAD's third axis. And now we'll change over to main piping, choose a different pipe code, and specify the size, and continue with the vertical pipe through the riser. A vertical pipe can be drawn from plan view as well, with up and down commands. And sloping pipe can be drawn from plan view or from any view. Sloping pipe can be drawn by angle, by ratio, or by a required vertical offset. And any pipe can simply be 3D rotated to become sloping pipe. Now the bulk main and the first cross main are completed. The other two cross mains and the office branches and main will be drawn off camera. And here you see they're done. The cross main in the 20-foot bay is at the same elevation as the branch lines, so the program automatically broke those pipes where they intersected. And everything is drawn in true 3D, whether at absolute elevations referenced to a control surface or drawn using AutoCAD's UCS. Now the sloping branch lines need to be connected to the cross mains yet, so we'll move to the next tool, Multi-Pipe Connect. The command name, Multi-Pipe Connect. You select a group of branches, and then we'll select a main to connect to. Finally, we specify the pipe name to draw. In this case, we're using a pipe name, riser nipples. And these names are arbitrary. You can use any names that you like. And here you'll see the riser nipples are sloping up to meet the branches. Now this same command can be run from any view. So we'll stay in a front view, select the branches in that first bay, and then select the cross main. And again, we'll use the pipe name riser nipples. Now, this tool will always draw the connecting pipes at 90-degree angles to both pipes being connected, even if each and every riser nipple must slope at a different angle. Next command we'll look at is inserting valves and a flow switch. Because the valves are in the riser, we'll go to an isometric view, and the command is insert valve. We select a valve from the dialog and then simply specify a location followed by the direction of flow, and then we have to indicate the direction of the valve handle rotation. And that valve literally replaces a section of piping, and that makes the valves very easy to stack. And here we'll have a second valve placed right on top of the first. We specify direction of flow, rotation of the handle, and now we have the command insert flow switch. Flow switches come as either saddle style or for use with threaded tees, as is done in residential risers. And you'll notice that the flow switch is actually placed a little higher than intended, and we'll fix that later. Now we'll take a look at the office sprinkler heads and connecting them to the branch lines. Now this is done with a very powerful command, the point pipe connect command. There are multiple ways to route these pipes, and we'll use a 3-pipe option to create goosenecks. So you select heads to connect, followed by a branch line, and the sprinkler heads are automatically connected using the routing option that you specified. The elevation of the arm over can be set relative to the branch line, relative to the sprinkler, or at some fixed elevation. It's just as easy to create a down over down or side outlet arm over. And even when the branch line is broken crossing the main, as they are here, the heads can be selected all along the run, and they'll be connected without creating overlapping pipes. And this command isn't just for connecting sprinkler heads to branches, it can be used to route piping between any 2 points. I will leave the 4 heads in the bottom right hand corner to demonstrate flex drops. Here you can see the goosenecks in single line view. So flex drops, these can be drawn individually or in groups. We'll use the multi-flex pipe command here, and you simply specify the heads to connect to a branch and select the branch. You'll notice an optional short nipple of hard pipe feeding those flex drops. The length and schedule of that nipple is fully adjustable. Next, we'll insert hangers. So the command is insert hangers, and we specify a hanger and then a length option. In this case, we'll reference a control surface. You can also set center to center length, or you can set a specific elevation to reach to. By using an offset of 0 inches to the control surface, we'll set the all-thread rod to terminate right at the level of the control surface. And you'll see we use the fence option to set multiple hangers at once. And you can also set them one at a time. And the next 2 bays will be completed off camera. The hanger rod lengths can be set, as I said, to an absolute elevation or to a standard center to center length. But by using control surfaces, we can cut the rods either above or below that control surface for drop-in anchors, bottom beam brackets, whatever you need. Now we'll look at common connection points. First, we'll insert the solid model once again. And solid model's been inserted here using the solid model command. Set the view style to realistic and take a closer look at the valves, the flow switch, and the hangers. You'll notice that each solid model portion is sitting in its own space. The office is over the office ceiling area, the main piping in the warehouse area, and flex pipes actually look like flex pipes. Now we'll use the common connection. This will tie the 2 systems together. You give the common connection point a name, any name, and then pick 2 or more locations. In this case, we'll specify the point on the riser where the office will connect, and then we'll select the point of the office piping that connects to that riser. Then we insert the solid model once again, and now the model is one system. Although you can see that flow switch is a little higher than it should have been. We'll fix that next. Have a look at those flex drops. So to fix the flow switch, in this instance, we'll simply erase the existing flow switch. Because it had broken the pipe, we'll use the merge pipes command and put those 2 pipes back into one, and then insert a new flow switch relative to the valves. So we set an offset distance, pick the pipe near the valve, and the flow switch is inserted appropriately. Then we'll insert solid model once again, and there's the flow switch in its correct location. Now we'll move into hydraulic calculations. First command we'll run is add supply. It's not actually necessary to define a source curve, but you do need to have at least one source point to calc. If you don't use a curve, you won't get surplus pressures, but perhaps you just need to determine the required pressure and flow for sizing a pump. But in this case, we'll specify a curve, and we set the location of the source. Next command is design area outline. Again, this is an optional command. We'll select the design area to be used. We have a polyline weighting, and this allows us to run the auto numbering command. The command is auto number heads. You specify the design area with sprinkler heads indicated inside. We select the head type that are in that area, and then pick the direction along the branch, direction along the main, and the program numbers up that remote area. If there were different head types within that outline, you could choose which ones would be noted. Now in the office, we'll insert sprinkler nodes one at a time using the add sprinkler reference command. Again, we select the design area. We specify a starting name and then select the heads to be included in that design area. You'll see information visible which can be quickly hidden from view, indicating the coverage area and required pressure. You can even specify that that information is hidden as a default. Now we'll use the command calculate design areas. You can calculate one, some, or all design areas. Then the result window will pop up showing us graphs for each of the calculated areas. In this case, we calculated both. We also see diagrams of each calculated area and a number of other options that we don't have time to show. Let's take a look at viewing and printing results. This generates a PDF style report which can be printed, saved, and searched on. It's laid out according to the requirements of NFPA 13 with some additional helpful information, and there are graphs for valves, pumps, and supply points. There's the beginning of the second calculation on the right. Once we return to the drawing, all required reference nodes are automatically added to the plan. And you can insert an optional, fully customizable results block. And it'll automatically update if you modify the calcs. Now we move on to stock listing. There are many commands involved with stock listing. We'll just walk through the list all command. This processes the entire model, takes it into our slick environment, and here you see the weld sketches for pipes with welds, pipes belonging to typical branch line. You can see all of the different pipes and fittings associated. And when we take a look at hangers, specific hangers have individualized details. There are numerous PDF reports that can be generated from within that interface. Back on the drawing, we've placed annotations for pipe sizing, cut lengths, line numbers, and weld tags. And these can be placed in either model space or paper space. And the annotations are completely customizable in terms of their text style, size, location, and rotation. And not shown here but also available are elevation tags that can reference the floor, structure, or absolute elevation.